Hi guys and girls on YouTube, welcome to my channel. In this video we're going to be looking at the Arcam AVR500 7-channel surround sound amplifier, and I'm going to cover one of the most common faults that this suffers from. So the repair under this is already underway, and as you can see I've got the top amplifier out. That's the bottom amplifier. That's got 4 channels, and then sitting on top of there you have another amplifier that's got 3 channels. Now if we take a look at the bottom amplifier, you can see how dark the heatsink is. If we move over to the top amplifier, you can see that it's dark this side and the actual colour's gone a lot lighter on that side, and that's a result of overheating. These amplifiers suffer very badly from overheating, and you can see how hot it's got by the change in colour of the heatsink. So in this video we're going to run through a few of the problems that actually causes this. So when you get one of these in for repair, the very first thing you must do is change all 7 bias pots. There's 4 on the bottom and 3 on the top. Now I've already changed these. These are replacement types I've put in. The original ones were a square one, a black body with a white insert for turning, and they are very poor quality, and over time I think what happens is the wiper oxidizes and it causes the resistance to change intermittently. So what you get is an amplifier that works for a bit, sorry, then it'll start to overheat, then it'll work a bit more, and that's probably what's caused this colour change here, because these transistors have got so hot. So if you look at these, I've changed all 7 pots. Now that's the first thing you must do on one of these amplifiers before you do anything else. Right, now the next thing we need to do is change 21 of these red caps. Yes, I did say 21. Now this is a particularly nasty fault, because these caps can change value with temperature, and also they can go intermittently open circuit. So if you take a cap out, it might read alright, but you put it back in and it works alright for a bit, and then when it warms up it goes open circuit. So the only surefire way to guarantee a proper repair is to change all 21, even if they test alright. Now I've got the old ones in there. Rather than write down the component reference numbers, I've put a list there of the ones you want to change, and also if we look at the amplifier, I've marked them, the ones I have changed, I've marked them with a black pen. So you've got 3 there, 3 there, 3 there, and you've got some more on the bottom. Now that's absolutely most important, and I'll show you why. Right, so here we have a brand new one under test. It's 33 PF, it's actually measuring 34.8, which was well within tolerance. And here under test we have one that I've just taken out the amplifier. Now I'll show you what's particularly nasty about this fault. This cap, when I first took it out, I tested it, it was alright. I warmed it up with a hairdryer, and let's have a look now. Now it's completely open circuit. So that is why you need to change all of those caps, even if they measure okay, because what'll happen is your amplifier will be working, the caps warm up, they go open circuit, and then the bias the bias current will suddenly shoot up from a few milliamps up to about 200 milliamps. Your amp starts overheating and it'll trip out and say fault on the front. So all of these, regardless of whether they test okay or not, must be replaced. Right, so this is the bottom amplifier board, and if you take a look at it, I've marked the capacitors that need to be changed with this black pen. So you've got on this board, you've got 4 class G amplifiers, so there's 12 caps. You've got 3 there, 3 here, and then we move over, there's 3 more there and 3 more there, so 12 caps on there need to be changed. But before we turn this amplifier on, I just want to cover one more very important point, and that is these driver transistors here. Now they're in the bias circuit, and the reason for that, it's got to track the temperature of its driver so it can keep the bias constant regardless of the temperature of the amplifier. Now the white zinc oxide paste, over time that dries up, and consequently the transistor is not in thermal contact with its driver, so it can't track the temperature. Now I've already done these 4 here, but I'll just move on to one of these and I'll demonstrate what the problem is. So if we take that one there and get the tweezers in, get the camera focused up. Now watch that transistor very carefully. That should be in a tight thermal contact with the driver, but watch what happens when you touch this. Can you see the transistor there is moving? So the white zinc oxide paste has actually dried up, and this transistor is no longer tracking the temperature of its driver transistor. So what will happen is, as the amplifier warms up, the bias will change when this transistor should be keeping it constant. Now that's just one. If we look at this end one here, if we can get the tweezers in. See, that's also moving about. So all of these transistors need to be removed off the board, clean up the transistor it's attached to, and we need to put some new white zinc oxide on, which if you look at these 4, that's what I've already done to them. Right, so as you can see, that's one of the transistors removed. Now all we do is you clean up the face of that, the white zinc oxide that's dried out, apply another dab of heatsink compound, and then we stick that transistor back onto the front of it. Right, so that's all the heatsink compound replaced. By the way, these things here, that there and that there, they aren't transistors. These are semiconductor thermal temperature sensors, and what they do is they sense the temperature of this heatsink, and then in the event of overheating, it'll signal the micro to shut down the amplifier. So we'll just turn over the back of the board now and have a quick look. What I've done is I've cleaned all the flux off with this flux remover. So if you take a look at the board now, it's actually impossible to see what's been replaced. Right, so that deals with replacing the faulty parts. Now I'll show you the correct procedure to bias up this amplifier. Right, so that's the 2 halves of the amplifier block. All we've got to do now is reattach that back onto there, and then fit the whole lot back into here, and then I'll show you how to set up the bias. Right, now this is how we set up the standing current in the output stage. You can see the bias preset there, and behind it there's 2 test points. If we look at the bottom, on the bottom board there's 2 test points there. Now what you do is you connect a millivolt meter to these, and we set each one of these presets roughly to about 2 millivolt. It's not critical, around about 2 millivolt, and we set all 7 to the same 2 millivolts first. Right, so we'll start on the top board. I've got a plug and socket, a plug that plugs into that socket there, like so, and then we connect that to a millivolt meter and switch the amplifier on. and that's the amplifier on. If we come over here, so I've already set the presets, 1.8 millivolt. That's okay, around about 2, because this is just the initial setup. It's not the final setup yet. So what you do is you set all 7 presets to around about 2 millivolt, and then you leave the amplifier running with no input signal for at least 1 hour. Now during that 1 hour, the top has got to be covered up like that. So we just put it on roughly. That's how it would be. Now you just sit, let it idle for an hour, no signal, no speakers, and then we start the procedure of setting the bias up. Right, so that's been sitting idling for over an hour with the lid on, so it's all thermally stabilised and up to running temperature inside. Now here's the procedure. On the top board you locate the centre channel preset, which is RV400. So as soon as we take the lid off, you've got to set RV400 to 8 millivolts. Then, as quickly as possible, set the other 2 presets on the top board, both to 8 millivolts, and then the board underneath with the 4 presets, you set all them to 8 millivolts. Now you've got to do this as quickly as possible, because once we take the lid off, it'll start cooling down. So that's the centre channel already set. I've already done that one. Then we move on to the other 6 as quick as you can. So there we go, that's it. Once you get the figure of 8 millivolts on all the channels, then the amplifier is correctly set up and all ready to go. Alright guys, many thanks for watching, and I'll see you in the next video.